Good evening, everyone, and welcome to tonight's Science at Melbourne public lecture. My name is Professor Moira O'Brien, and I have the great pleasure of being the Dean of Science here at the University of Melbourne. First, I would like to begin by acknowledging the traditional owners of the land that we meet upon today. They are the Wurundjeri Woiwurrung people. I also acknowledge the traditional owners of the lands of the people who are joining us online. Aboriginal and Torres Strait Islanders are Australia's first people, are also the first scientists with deep and enduring knowledge of the lands and the waters and skies. And I pay my respects to all elders, past and present, and I welcome all First Nations people joining us this evening. It is my pleasure to welcome you to the second event in the Science at Melbourne Lecture Theatre series for 2025. These lectures are some of my favourite events in our calendars as they provide the opportunity for the faculty to share its knowledge and passion for science with the wider community. They allow us to share the work and insights of our amazing researchers and explore some of the most pressing issues facing the globe today. The title of tonight's discussion, Don't Drink the Water or Breathe the Air, Pollution and Solutions, was inspired by the 1965 song Pollution by Tom Lehrer, which was, you may have heard just a tiny little bit of it just then, but we'll also play the full version later for those who haven't heard it previously. It was written 60 years ago, but many of the lyrics are still of great relevance today. This lecture will be recorded and it will be available online in the next couple of days on the Faculty of Science website. We'll also email you the link. Feel free to share it so you can watch it at your leisure. We will also be hosting 2 more Science at Melbourne lectures for this year, as well as several other events which I encourage you to join in. The next lecture is going to be entitled How to Think Like a Spy, the Science of Intelligence, and that will be held at the start of our 11th Annual Science Festival on the 6th of August. More information on the Science website. For those of you who are attending in person this evening, we encourage you to enjoy the refreshments in the foyer, to talk to our speakers and other attendees after the lecture. Now back to this evening's discussion. Our panel will delve into one of the most pressing environmental challenges of our time: the alarming rate of pollution affecting our planet, our health and our future. We are living through an unprecedented global experiment. Every day, people and ecosystems around the world, including those in some of the most remote areas of the globe, are being exposed to an ever-growing mix of chemical pollutants from a multitude of human activities. We lack critical information on how these chemicals behave in the environment, their toxicity and their long-term consequences for ecological and human health. Now, tonight's conversation isn't just about highlighting the problems, it's also about hope and action. Our distinguished panel of experts will offer practical and achievable steps that each of us can take in our homes and our workplaces and our communities to make a real difference. Working at the forefront of this field, our 3 panellists are not only uncovering the risks of pollution, but also pioneering innovative approaches to reduce the production, persistence, and impact of harmful pollutants. Through their research and advocacy, they are helping to shape a more sustainable and healthy future for all of us. Our moderator will introduce our experts in greater detail shortly, so instead I will focus on introducing her. Dr. Lara Grollo has been part of the University of Melbourne Faculty of Science community, indeed family, since she completed her Bachelor of Science with Honours and then her PhD here. Lara is based in the School of BioSciences and her research interests include viral vaccine design and antiviral discovery. I also know from student comments and the comments of many of her staff, she is also a crackingly good teacher. So she was a perfect choice for tonight's panel. She's a senior lecturer and she's dedicated to inspiring students and communicating research discoveries with the wider community. And so it is with much anticipation of a really important and interesting discussion that I hand over to Lara. Thank you.
Thank you, Moira, for that lovely introduction. I'm glad she didn't say when I completed my bachelor's, because that might give away a little bit of my age. Now, Moira has done a fantastic job on telling you what we're here to talk about tonight. I did want to preface one thing and say there's a couple of things we're not going to talk about tonight. This lecture series is fantastic. If you haven't watched it, I highly recommend going back and watching it. And the last topic that we spoke about was climate change. So there was a lot of information that was discussed by an expert panel about climate change and how that was affecting us. So tonight we're going to shift away from that and look at it more from the pollution perspective. And so we have a fantastic panel of people here that are going, you can question, you can pester, you can interrogate, and try and get from their minds the information that you want. So we're going to start off with Professor Brad Clarke. He's also an academic here at the University of Melbourne. He is a professor in environmental science and analytical chemistry and is the chief investigator in the Australian Laboratory for Emerging Contaminants. His research focuses on the risk to public health and the environment from pollution, focusing on synthetic, I am not going to be able to say that, I'm just going to say PFAS because I know he's going to explain what PFAS is. So PFAS, microplastics and flame retardants, as well as advanced mass spectroscopy techniques. Now, before I let Brad jump in and give you a little bit of introduction about himself, I also want to let you know, sitting next to Brad is Suzie, and Suzie is another academic here at the University of Melbourne. She's an associate professor and an Ecotoxicologist and soil chemist. Suzie and I are from the same school. We're both from the School of BioSciences, and Suzie's research concentrates on safeguarding the environment from impacts of soil pollution and investigating how contaminants like microplastics and PFAS and heavy metals affect soil and ecosystems. Her research provides important evidence to help government, industry and communities assess risks and make better decisions. Suzie has also worked with and for the EPA, so she has a broad sense of knowledge in the area. And sitting next to Suzie is Dr. Victor Kabay. Victor is an environmental risk management specialist. He has over 20 years of experience in the industry, in consulting, in state government, also in academia. He currently works as a National Senior Environmental Advisor for Cleanaway, specialising in risk management, assurance and environmental investigations. He's also an Honorary Fellow of the University of Melbourne in acknowledgement for his ongoing support to research and teaching at the university. And Victor's academic pursuits are mostly focused on understanding how risk-based decisions are made along the entire life cycle of pollutants and how we can ensure that these decisions consistently protect the environment and the people who live in it. So before we jump into asking everybody some questions and having a discussion, we'd like for each of the speakers to do a little bit of an introduction for you so you can get to know them, their work and what makes their minds tick. So we'll start off with Brad. He's going to have a little bit of a chat about what he does.
Thanks very much, and thank you all for being here and sharing your Wednesday night with us. I'm actually going to start with some sobering figures around pollution. So pollution is actually the largest environmental risk factor for disease and premature death in the world today. It's estimated that around 9 million premature deaths occur each year due to pollution, and that's actually 1 in 6. To put that into perspective, pollution causes 3 times more deaths than from AIDS, tuberculosis and malaria combined, and 15 times more than from all wars and other acts of violence. Chemical innovation over the last century has transformed modern life, from medicine and agriculture to materials and technology, improving health, productivity, and the overall quality of our life. Today, the global chemical industry exceeds $5 trillion per year, and it's expected to double by 2030. But alongside this growth, we have this worrying rapid expansion of chemicals being introduced. We have 350,000 chemicals registered for use worldwide. Concerningly, many of these are unknown or ambiguous in their identities. We don't know about 120,000 of them because they're confidential or poorly defined in national registries. We see the regionalisation of chemical manufacture, which means that we need to have our own monitoring programs in Australia, and we cannot rely on research from overseas. Leading researchers have now concluded that the safe operating space for novel chemicals, and it's called a planetary boundary, has been exceeded simply because production is outpacing our capacity to assess and monitor their safety. PFAS, which is the easy way to say per and polyfluoroalkyl substance, are commonly referred to as forever chemicals. And they illustrate what happens when chemical innovation and public health collide. Used for decades, PFOS, which is a type of PFAS, was eventually found in every living organism on Earth, including all of us. Worse still, PFAS manufacturers knew of the health risks as early as the 1970s, but failed to make that information public. When some harmful PFAS were phased out, the industry responded not by stepping back, but by creating thousands of new alternatives. There are now over 9,000 different PFAS compounds, most of which we know almost nothing about in terms of their environmental fate or health effects. When harmful chemicals such as PFAS find their way into the environment, typically the burden of cleanup falls on taxpayers. Europe, for instance, is facing an estimated €170 billion bill to remediate PFAS from the environment, which dwarfs the original $2 billion of the original industry. And for the very depressing last fact, today children are born pre-polluted, with PFAS, pesticides, plasticizers and other toxic chemicals already in their bodies. These exposures can impair brain development, increase cancer risk and damage fertility. Some of the worst offenders are called endocrine disrupting chemicals, or EDCs, and they interfere with our hormone systems. We've seen a 50% drop in men's sperm counts, and birth defects of reproductive organs are rising globally, which are thought to be related to chemical exposure. To quote Rachel Carson, author of The Silent Spring, "For the first time in the history of the world, every human being is now subjected to contact with dangerous chemicals from the moment of conception until death." The truth is, we are running a chemical experiment on all life on Earth, and we are gambling with the health of current and future generations. The challenge before us is not to halt chemical innovation, but to ask, where is it truly needed, and what is the real price of our convenience?
That is quite sobering, but I think it also demonstrates how important this topic is and why this university is attempting this research and trying to look into this, and also why we're inviting you along tonight to join in that and also ask the questions. Next, we will have Suzie, who's going to be talking to us a little bit about her work in the area and how it all fits together.
Okay, hi everyone. I'm going to get a little bit of audience participation now. So put your hand up if after listening to Brad speak, you're a little bit depressed. You're a little bit like, what's in my water? What am I breathing in? What's in my food? And keep your hands up. Now put those hands down if you're like, how do I actually make a decision if that's safe or not? How much am I getting? Like, can you make that decision? If you can't, put your hand down. Okay, so now what we're going to do is talk a little bit about how the area that all of us work in, which is called environmental risk assessment. And it's, if we can have the next slide, yeah. So basically the premise of environmental risk assessment, it's used all around the world. It's standard methods that we use to go from that sort of like, whoa, this is scary, to being able to make evidence-based decisions. And so the key principle that underlies environmental risk assessment is this idea that the dose makes the poison. And so this is a summary of what a Swiss physician called Paracelsus said about 500 years ago. And the idea is that you need to have enough of something present in your food or your water for it to be toxic and for you to need to worry about it. And like down the bottom, I've got, like everything can be toxic if you have enough of it, even water. But conversely, it also means that just because something's present, like for instance, you might have seen some of the recent articles on microplastics being in our brains, which is pretty concerning, but just because it's there, it doesn't necessarily mean that it's having a toxic impact. And so then the next thing that we pay attention to in environmental risk assessment is what we call the source pathway receptor model. I'm going to quickly give you 2 examples to illustrate how we use this. So a really sort of common form of pollution that you might think of is a factory that's like releasing some sort of chemical out through its chimney stacks. And so that's the source, and it travels through the air to the human who breathes it in and becomes the receptor, the receiver of that pollution. But another source pathway receptor that you might not have considered, and we have a lot of these ones that are not as classic as coming from industry, is that, many of us take medicines at different times. So it might be, say, paracetamol or the contraceptive pill or antidepressants, and they contain chemicals. They're chemicals that are meant to act on biological organisms where it's target organisms, and it does really important stuff. And I want to make it clear, I'm not suggesting you don't take your medicine, but I do think that we need to think about the impact it's having. And I'm going to talk about a little bit later just how we deal with things like industry different to how we deal with things like medicines. So the source in this case is the medicine. You take your medicine, it has its impact on its body. Some of it stays in your body and breaks down, but actually quite a lot of most medicines ends up when we go to the toilet, passing through us and out into the sewer system. And then it goes to the water treatment plant where it's treated. And some of it goes onto our agricultural fields for irrigation, and the solid part, what we call the biosolids, because it sounds better than treated sewage, goes onto fields where if there's any chemicals left, of the sort of polluting chemicals, it can end up in plants. And then if we eat those plants, if they're vegetables, it could end up in us. And then a lot of our treated wastewater also ends up, we release it out into the oceans. And so here I've got as a potential receptor some fish out in the oceans. And then down the bottom I've got this little sort of quote: if you break the chain, you reduce the risk. And so this is a really important part of being able to utilise environmental risk assessment. If we stop this source pathway receptor chain, we can really, really reduce that risk. So for industry, we would normally tend to make them stop it being released out of their chimney stacks. Whereas for medicines, because of course we want to take our medicines, we would normally end up more working with it at the water treatment plant rather than saying we don't want people to take medicine. And then the last kind of concept to do with risk assessment that I'm going to bring to your attention today, we do a whole lot of different equations, but our main, can I go back? Yeah. Our main equation that brings it all together is this one: risk equals hazard by exposure. So that dose makes the poison. That's around the toxicity, and that's what I'm talking about when I was saying about the hazard. And then when we talk about that source pathway receptor, we're talking about your exposure to contaminants. And so literally we are able to multiply the hazard by the exposure and get a measure of the chance of that having negative impacts from that pollutant. And so that enables us to make some decisions. And so by using risk assessment, we're able to identify potential risks, we're able to assess them, and then we're able to use that knowledge to protect us and the environment. And so it means that we're doing this based on evidence. It means that we can use it to create policy. It means that we can use it to prioritise what pollutant issues we need to pay attention to. So we're not putting our resources into things that aren't really a problem, and we can put them into the issues that really are harming our health and harming the planet's health. And overall, though, it gives us this evidence basis that we can use to make those decisions. Industry can use it to make the decisions about how they're going to work within the policy that's been set by government. And so I hope that's given you all a bit of an understanding of how we can go from that kind of concern, fear-based place to being able to make some decisions that protect us from pollution.
Thank you very much, Suzie. Now, it wouldn't be a panel discussion if all we had was academics doing research talking to you. So we do have Victor, who's here, who's from industry. I had a chat to Victor before, and he was telling me that he's been in academia, he's been in industry, he's been in policy. Essentially, he's been involved in environmental pollution from all different aspects. So he has a very unique offering here in that he can give us many different perspectives. Victor doesn't have any slides, but can you tell us a little bit about your involvement?
Absolutely, and thank you very much. Thank you so much for having me here today. It is an absolute honour to be here. Can I call myself a professional butterfly, if you will? Someone who's fluttered from one profession to the next, but always in the world of pollution, because of course we love pollution and we love working in it. We can't help ourselves. But so what I thought I'd talk about, without any slides this time, was about the machine, if you will, that regulates pollution out there. In a way, so pollution is not a new thing. Pollution has been around for a very long time. And there is a machine that governs it. When I say a machine, I mean the government and industry and people and everyone in this room and everything is part of this machine that tries to minimize these risks of pollution. And what Brad said before was absolutely relevant. The machine fails often. Very often, you could even say, but it does exist. And I thought I'd at least give you a little bit of a background on some of those elements, just based on places I've worked in and things like that. So one of them is, when a new product comes into Australia and a new product is developed, it has to get assessed. There's a whole team of toxicologists up in Canberra who do the whole work, and there's a whole process. And there's quite a lot of work that goes into it. Is it perfect? It's not perfect. Is it pretty good? It's pretty good. But this is the thing, so we need to be careful. It is one of those things, there is a system, and we need to be aware of it. And when you work in our fields, you're trying to find all the gaps in the system because you're trying to fix those gaps. That's exactly what you're trying to do. All the therapeutic goods go through the TGA. All of the veterinary chemicals go through an organization called the APVMA. There's all these associations that do this. Then, of course, there is the responsibility of the people selling the products. And there is a lot of responsibility that happens there, and how it is marketed and how it is sold and what information is provided and what information needs to be provided. Then, of course, there is what happens when something goes wrong. The regulators have an enormous amount of influence on this. And when I worked at the EPA, it was amazing. It was an incredibly vibrant and stressful place to work. I'm sure Suzie will agree with me on this, because there was always something going on, and it was always something that you would have never thought in 1,000 years would have happened. And so they, of course, write policy. We think of them as the policy writers, and of course they do that. But they do more than that. They also are the environmental police, if you will, and which obviously is extremely important. They also do a lot of other things. They license all polluters. The EPA are the ones who, if you will, allow pollution, but they'll allow it to happen at levels that will be safe, as what Suzie was saying. The dose does make the poison. Then there is incidents. What happens when there's a horrible incident and there's all of the first responders that are involved in it? That is a huge piece of work. Can you see how there's this whole machine involved in the management of pollution? And I'm only telling you a couple of them. City councils play an enormous role, and everyone in this room does, right? Our decisions every single day make a huge impact in terms of what gets released, because there is however many billion people on Earth, and 26 million people in Australia. If we all pour a litre, it's 26 million litres, right? So it's a lot. So our collective contribution to pollution can be I rhymed by accident, sorry. It can be quite significant. So it is something that we absolutely need to consider. So I just thought, when you think about pollution, don't think about it as just this one bad thing that happens. There is an entire architecture, there is an entire machine around it that, as I said, not perfect, which is why we have incidents, of course, which is why everything Brad said is absolutely true, right? But it doesn't mean there is no controls, and our job is constantly to try and improve that machine. Thank you.
Thanks, Victor. So on that note, I want to ask you guys a couple of questions. And you've just spoken about how big this machine is, that is regulation, controlling, researching, identifying all aspects of pollution, and then also how big the problem itself is. It's massive. Brad spoke about hundreds of thousands of chemicals. We've spoken about 26 million litres worth of water going through. So it is a very big problem. So what I'd like to start off with is asking you a slightly narrower question. And I want to know, what pollution problem keeps you awake at night? Brad, can I start with you?
Yeah, I'm happy to go first. It's called chemical substitution, which I sort of talked a little bit about in my PFAS answer. So what we're currently doing is not learning lessons from the mistakes of the past. So we discover a problematic chemical, and then the industry synthesizes a new variant of that. Typically, the premise of this is so that the people who buy that product don't have to change any of their processes. So I'll give you an example of this, bisphenol A as well. A lot of people want to buy a BPA-free cup. Now, so what happened was we don't buy BPA, but there's 30 different analogues now of bisphenols, and one of them looks remarkably like DDT, which is a pesticide which we know is toxic. So we're moving from this situation where we have something we know about to a situation where we know nothing about largely. And we see this happening in almost every single chemical class that I study. PFAS, flame retardants, pesticides, it just happens over and over and over again. And we're not learning our historical lessons, and we're not thinking about the machinery that would help prevent this as well. So as another example of this, PFOS has been largely banned in Australia, and it's been replaced by this novel one, and I have that in my blood. It's only used in China. How did that get into my body? And it gets imported through products as well. So that's my thing that I'm concerned about.
That's very scary. I think it's going to keep all of us awake at night. I don't think anyone's going to sleep after tonight, maybe. Suzie?
So my big thing that keeps me up at night is, as Brad mentioned, we've got hundreds of thousands of chemicals, and a lot of them, really the only people who know anything about them are the industries that use them. And so how do we deal with this large number of chemicals and get the information behind them so that we can do that risk assessment, so that we can make the evidence-based decisions on them?
Victor?
Can I have two?
Sure.
So because I think with pollution, you always have to think there is very much a human side, and then there is the ecological side, and I always think of them so separately. But you know, when Brad said that, what was it, however many million people die every year from pollution, was it 9 million? 9 million. The vast majority of them are from one pollutant. And I don't know if anyone here could guess which pollutant. It's not a sexy pollutant. It's the, which one? No, a pollutant, environmental pollutant, not toxic substance, which alcohol is totally a toxic substance. I meant environmental pollutant. Air pollution, it is a type of air pollution, it's the fine particles in the air. PM 2.5 as it's known, the particles with a diameter less than 2.5 microns, you can't see it. So people think of dust as the dust you sort of sweep up. It's not that kind of dust, and it comes from combustion sources, from cars. Remember when I said earlier, like, it's a lot of our behaviour affects this. It's mostly cars, and actually in Australia, bushfires, major sources of this. And so they, you know, sadly, I mean, if I may add to the catastrophic nature of, well, if anyone remembers Black Saturday, more people died from smoke in the cities than died in the fires. The smoke was more deadly, right? So this is just a thing to remember. So that's the one that keeps me up at night, and I live 200 meters from the city link, so, you know, so that does keep me up at night. And the other one is, I don't even know if it is pollution, I have to be honest, and that's the one that worries me partially, is the fact that there is an estimated 40% collapse in insect populations on Earth, and nobody knows why. That one actually keeps me up at night. Pollution is meant to be part of it, and I know there's other elements. There's habitat loss, there's climate change, there's a lot of other things. So let's not pretend it's just pollution, but 40% is a lot of something that is the base of our ecosystem globally. So that one really worries me. And for all it's worth, I asked AI on the way here what it thought the worst pollutant was, and it agreed with me. It said PM 2.5. So there you go.
So maybe you as the audience hadn't thought about this beforehand, and perhaps at the end of today you might think when you leave here about what pollution problem might keep you awake at night, and hopefully we'll get a chance to sort of go into these in a little bit more detail and have a bit more of a discussion and create a little bit more understanding around some of these issues. So I want to ask, what role should scientific research play in shaping environmental policy? And how can we better connect scientists, policymakers and communities, aside from nights like tonight? Suzie, would you like to start?
Okay, yeah, I'll start. So I think science and research, we play a really important role because, well, actually we have a number of roles. I'm just going to pick one. And I think it's that we're independent, relatively speaking. So we can go out there and we can do the research and not on whatever we think are the important things and not worry about, you know, like if the organisation we work for is going to have some sort of issue with that. And so it means that scientists have actually identified a number of these pollution issues. Like it was researchers, for example, who found PFAS out in the environment and, you know, kind of rang the bell and said, hey, it's out here. We thought it was all contained within industry. What should, you know, like, is this a problem? Let's do some research, let's find out, and then let's make some decisions.
Victor, I see you nodding quite aggressively there.
I think I owe everyone an apology. I can't believe when I spoke about the machine before I did not list research in it, which is the absolutely critical element, possibly a foundational one. I'm sorry, so apologies to everyone. But yes, no, I absolutely agree with everything Suzie said, and research is absolutely fundamental. And I think but I think I want to raise that I think research has challenges when it comes to pollution, because pollution occurs in a non-controlled situation. It occurs often as a result of an incident, right? And universities are the last to hear about it, right? So it's a really difficult place, and I'm very sympathetic to the universities when it comes to this, that, you know, first of all, so many pollution problems are commercial in confidence or under legal privilege. That's the reality. When there is a developer developing a new block of land, they're not going to tell everyone exactly how polluted that land was before they cleaned it up. Right? They're not going to do that. They're just going to clean it up, right? And that's true. It's not. It's not good or evil. It is just the way, again, if you will, the way the machine works. But that means that a lot of the scientists are locked out of all of this because they're not privy to any of it, which is, I feel that it's always such a lost opportunity when it comes to that. And of course with incidents. Incidents are a big thing when there is a spill, when there is some kind of a big release. You know, the government is the first one there, and of course the first responders and industry are all over it. And unfortunately, you know, academia or the researchers can only really get involved in sort of looking at the impacts way after it happened. And also because, you know, you can't cause a pollution incident, can you, as part of your research? So you don't have a before and after data set either. right? You can't just, it would be amazing, right? If it wasn't the most unethical thing in the world to just get a nice river, dose it with a whole bunch of chemicals and see what happens. Scientifically amazing, also the worst thing you could possibly do, right? But again, so I feel that this is a challenge that researchers have, which means a lot of the research focuses on the things they can control, which means of the 100 things they could look at, they can only look at 20. I'm making up the 20, but you see, and so there is a whole bunch that nobody can look at. And so it's a concern of mine.
Yeah, that I think that's a concern for everyone's. But Brad, you told me that you did some research work based on the incidents, that you were involved in some work where you were looking at some of the, when an incident has happened, what the impact of that is. Do you feel that it is a delayed response in terms of academia? Do you think we should get into it a little bit more? Sorry, I've put you on the spot there.
No, that's actually totally fine. So the students in my group will like to call themselves pollution patrol. So, and then they want me to buy like a little beat up car, ute, so whenever there's an incident, they can drive out there and collect samples. So there was a big Footscray fire in 2019. It was the largest urban fire in Melbourne's contemporary history. And it was actually a chemical warehouse stockpile, and then debatably people set it on fire deliberately. My students went out and got samples from that event. I'll say it was from my previous job. But so we were able to get some really interesting data. And I think actually this is an example of where I think the EPA should be collaborating with labs like mine, because I have really specialised equipment in my lab and we're really good at using it too, that would actually inform what types of chemicals were released. So the types of information I can generate for EPA is actually not available for like a commercial laboratory. So I think that there's a lot of opportunity for that collaboration. I really like to also, just to go back to what Suzie was saying, I think there's, there really does need to be independence of science from the end users as well. So we do need to be able to be fearless in how we go about generating findings, and whether it's controversial or not, we should just be able to put that out there. I'm going to use another example, if that's okay. Our pollution patrol is now extending to looking at PFAS in drinking water around Australia. So we've done a citizen science program where we've asked people to mail us in their water samples. Boy, oh boy, did that cause a bit of a ruckus with the water utilities, which I wasn't fully expecting. I mean, I guess I probably wasn't really expecting thank you, but it probably would have been nice. But so I personally believe we have a right to know what we're drinking. And one of the things that's really surprising to me as I travel around Australia and talk to communities is the level of distrust people feel for the EPA and the water sector. And I've always found that quite surprising, because I've worked very closely with both of those sectors, and I know how professional and how well-intentioned all of the people are in those organisations. But it doesn't change the fact that the community feels this distrust. And I think that this is where independent science can help support the narrative that, say, the EPA or the water sector wants to put out.
Thanks. That citizen science idea is something that we see flowing a lot more into all scientific research at the moment, and it kind of gives people a feeling like they're involved in the research. And I think that tangible, I'm included in this, is something that people really enjoy. So along with ideas like citizen science and maybe collaboration with the EPA, what other innovative approaches or solutions give you hope in tackling the environmental pollution over the next decade or so? Or if you don't have any hope at all, you can also let us know.
Do you want me to go first? You go first. So I know, I normally start my talk with, I'm going to be a bit depressing. And I know that it is a little depressing, some of the things that I'm telling you, but if we're not aware of it, we can't fix it. So actually I see this message as very optimistic. So first step is we need to know there's a problem. And I now teach into a school of chemistry, and a lot of the chemists just, I've made a really cool new molecule. What might happen to that in the environment? And it's a question now that some of the chemists who are going to be leading the chemical industry, probably in Australia, are starting, hopefully continuing to think about and take into their professions. So that's some of the change that I'm happy about.
Yeah, that's good. We don't know what we don't know, so as long as we can acknowledge that, we can move forward in a potentially better pathway. Suzie, do you have any ideas of how you think or what hope we have in the next 10 years or so?
Yes, I mean, I think we've all got to have hope, or else it's a bit hard to get up the next day. I mean, part of the hope I have is that I feel like I'm part of the solution, which, is a good place to be. But I really like the way our environment protection authorities around Australia, and Victoria's included in this, are moving really overtly towards this kind of risk-based approach. Before, there were a lot of levels where they literally had gone, like, people, a whole lot of experts in the room and gone, yeah, where do you reckon we should set lead? And they'd be like, oh, that's a bit too high, let's put it a bit lower, And that was how they'd set a lot of the limits in the past. Whereas now the environmental thresholds are being set with this risk assessment approach, and just in the last 4 years, have I got that right? It's actually become an official part of EPA Victoria's approach, that they're taking this evidence-based approach to things. And so I think that this is something that's really positive.
Do you know there actually is a name for what you were talking about? It's that hilarious acronym. It's called GOBSAT, which is good old boys sitting around the table. Right? I know it's terrible, but that is totally how it used to be done. And I'm talking decades ago, of course, but that the fact that it even has a name tells you how frequent that was. Look, at my end, I am hopeful for, I think, 2 reasons. One, and maybe I'm just telling myself this, but I'm also a little bit of a pollution historian, and things used to be extremely bad. When the EPAs were created in the 70s, it was partially as a result of a smog event in London, which killed thousands of people in one day. And this is in London, okay? And I'm just saying, I mean, you hear stories, when I was at the EPA, you hear these horror stories from people who had been there from the start of the EPA. And they would tell the most amazing stories about how the Maribyrnong used to be purple, right? From the dye works upstream, right? The Mary Creek used to be called Industrial Drain 48, something like this. Like, that was its name, right? So maybe I just tell myself this to feel better, but I do think things are better in general. Now, but that absolutely does not remove the need to do better, right? So, those two things can both be true at the same time. So that's the first one. The second one is, PFAS teaches us a lot of things. It teaches us a story about academics not getting listened to for decades, right? It's all right for me to say it, I think, because you'd come across as whingers if you said it, but if I said it, it's okay. But it also, once it did get the spotlight, analytical tools were developed at honestly a pretty amazing pace, I think. And then the remediation and of something that is found in trace amounts, very, very, very small amounts. It's not easy to treat PFAS, right? And it's chemically extremely stable. It doesn't like to be destroyed. That's why it's a forever chemical, or forever group of chemicals, sorry. So the fact that could have moved so quickly once there was a bit of fire under it, that does give me hope, right? Maybe I'm wrong with that, but I do believe that.
This is really interesting that you're saying that we are doing better than we have done in the past. But it seems as though every time we're doing better, it's because of some catastrophic event. So how do we change that mindset? Is it the way Brad spoke about in terms of realising we don't know what chemical we're creating or what impact it's going to have, so we need to investigate that as well? Sorry, Victor, you're going to answer?
I'm in 2 minds about this because, of course, in government they say, don't waste a good crisis. Of course, they do say it. And it's not just in government, you say it everywhere. Fine, it is true. That does create momentum. I've always been in 2 minds about this because, in a way, academics are the first to spot it. That's almost always the case. The research is the canary in the coal mine. always, almost always. And on the one hand, they have to raise these issues. So in a way, they are, the crazy person in the street or the board saying, the end is nigh. That's what they... And I've wondered, on the one hand, they need to do that to get the stage time to be able to raise the issue. On the other hand, they often make issues sound much worse than they are, right? And I'm like, that can happen, where it's like, oh, we don't know, therefore it's horrible. And again, like the paper with the microplastic in the brain, like that one did the rounds. The amount of anxiety that one paper caused on Earth is immeasurable. And the reality is we have no idea if that actually caused any harm at all, right? And I honestly do not know what researchers should do, right?
As researchers, do either of you want to comment on that thought?
What we should do? I think there's needs to be sort of in this space, because we do have to put ourselves out there, and that's like part of tonight is putting ourselves out there. And we will get some things wrong. We will toll the bell really loudly on some things that maybe don't need to be. But that's all part of the process, because if we're worrying too much about it and waiting until we've got all the evidence, it's too late kind of thing. And so we want to be doing that. And I just wanted to talk about microplastics a bit more, because I think microplastics is a really interesting pollutant, because it's the first one in a long time that's been really driven by the public, by you guys. We don't have the evidence yet to say, we know that it's getting into like seabirds, and that's pretty scary, but a lot of the things that are being claim they're being based on that, like we find it in our brains, we find it in our food, we find it, I know people who won't eat seafood because microplastics have been found in seafood, but they don't know it's also in our honey and our beef and our salt and the milk and pretty much wine, beer, pretty much anything you eat, they've found microplastics in it. And we don't know if those levels are toxic, but there's something about microplastics that's really captured the public's imagination, and they have driven governments to do something about it, about plastic in general and microplastics too. And so I think it really demonstrates how all of you guys and the decisions that you make and what, how you vote and what you do with your consumer your money, where your discretionary funds, that has an impact on where we go and the decisions that are made and how much emphasis is put on pollution from a political point of view.
Well, with that in mind, what practical steps can individuals, the audience, me, you, Brad, Victor, what can we take to reduce our contribution to the problem, reduce our exposure to potentially harmful chemicals, and also promote that awareness that's going to make the changes occur? Do you have any practical steps of how we can achieve that?
I can talk about what I do.
Tell us what you do.
So I use that principle I brought up earlier, the dose makes the poison. And like all of you, I have to put my hand down when we're talking really generally. I don't know exactly how much I'm exposed to. I don't know exactly what's in my drinking water. And so I'm always thinking about what are easy things that I can do to just reduce that dose of the things that I know are in there, and also the things that I don't know are in there, so that I can just if I can get that dose low enough, maybe I'm getting it below the threshold. So, I do things like we have really good quality drinking water in Australia relative to a lot of countries, and like drinking water out of plastic containers, the disposable plastic containers, we do know that stuff leaches out of them. So I try to not as often as I can. If I really need to, then I do. I'm never really pedantic and extreme about it. I don't microwave things in plastic containers because we know that chemicals leach out of it. I do think about do I need to use this piece of plastic, or could I reuse this piece of plastic? I did a thing once for a talk called My Plastic Day, and I touched in my day, and I'm someone who tries to reduce my plastic use. I touched 98 pieces of plastic. You know, it's a big problem, and anything I can do to reduce that is good.
Brad, do you have any comments?
I have a few suggestions as well. There's chemicals and things you may not expect for women, for people who wear makeup. Surprisingly, PFAS was put in there as a major ingredient as well because it's oil and water repellent. So there's also been studies that have shown that actually that it can go through your skin and into your body. So that's probably one area that you could make steps. The second one would, and actually foundation also has microplastics in it as well. So again, just delivering the bad news for people tonight. But I think in terms of food's probably the big one. Food's often a really big source of exposure to chemicals and the plastics that you might store them in or have them delivered in. So be careful. I'm not saying don't ever get takeaway, but maybe think very carefully about the sort of how you store your food and then how you reheat it. So in my household, we don't store any food in plastic. We store it all in glass. Personally, I don't get takeaway coffees as well because the inside layer of the coffee cup has in the past been different types of PFAS or different types of chemicals. Also, it's adding to the waste problem. You don't really need to get that takeaway coffee cup. Take your keep cup and things like that. So, and I think I think things like carpet as well would be something to be really mindful of too. So things in your home can actually introduce chemicals. So dust in your home is actually quite laden with a lot of industrial chemicals. So being a bit mindful of the fact that, say, if you had young children, probably making sure that that you try to minimise that exposure to dust would be pretty good as well. So they're probably some key ones.
Victor?
First, I can't help it, just from working at the EPA, there was a couple of resources that I think I really do want to share. If anyone's asthmatic or suffers from respiratory illness and all of this, AirWatch is your best friend. It's an amazing website and it tells you, because especially people who suffer from asthma, it really does make a difference. EPA has amazing monitoring data, so I'm sorry, I had to throw that in there because it's amazing. And I think is it Beachwatch or the Beach Report? Also, Beach Report for swimming in the ocean, because you all know, like, the water that goes into Port Phillip Bay is not just rainwater. There is also all the stuff from the roads. So after a big rainfall, sometimes the beach is not the best place to be. So definitely look at the Beach Report. But at my end, I mean, I do try to buy organic, actually, but I do, I'm sorry, but it's true. And incredibly, because I'm crazy, it's not because of what I'm worried about ingesting, it's because of the ecological effects from the farms. It was interesting. I was really thinking about it before coming here, and I was like, that's why I do it. So that was the bigger interest on that front. And so that's just on my end. And but that's pretty, obviously, I try to use, as you can tell, I try to keep my makeup to a minimum. So Brad's issues are not going to be a problem for me. But with personal care products, so shampoo and all of this, I will get the ones that do not have any of the EDTAs and any of that kind of stuff, because the reality is that stuff goes straight into the ocean. And so it does not really get treated at the treatment plants that well. So those are the two things I probably do the most of.
Thank you. So there's some food for thought for all of us to think about as we move about our daily life. Just small little steps can actually have a larger impact when a lot of us are doing them. You've been listening to me ask the panel some questions, but perhaps that's brought up some questions in your mind that you feel that you might want to ask them. Is there anyone in the audience that has a question that they would like to ask the panel? But maybe we can start off here with.
I was just wondering, I was quite struck by when Suzie was talking about the effect that the microplastics sort of had on the society and kind of how we think about the microplastics. Does any of the panel have any ideas about why microplastics have struck that chord and how we could maybe bring that into other areas, other pollutants?
I think it's the pictures of dead birds with plastic in their stomachs, full of plastic, and also fish, but particularly the birds, I think have had a really big impact. And so I guess that sort of comes back to what we were talking about before, about how, like, that was academics going out there and putting those pictures of birds out into the press and making sure people saw them. So it's the sort of the importance of us doing a bit of those scare tactics, I think, even though they're maybe not seen as being so savoury to be doing.
Yeah, I think it's because we can see them. So when we see microscope images of like small particles in environmental samples or tissues, people can see it. So it becomes less abstract. So like a PFAS, we can't see it. And so it becomes real. And that's why I think it gets a lot of media coverage as well, which often is sensational, which is a little concerning too.
Do you have anything to add there, Victor?
Look, I don't know. I wondered if one of the other reasons, because I don't want to repeat what my fellow panellists have said, is, plastic is the bad guy, right? Because of, we know that through recycling we're trying to... So I think that message was already embedded in us for quite a little while back, like you have to recycle it, you have to put it aside, it's a different thing. We need to minimise our plastic use. So that was already there to begin with. And then this happened on top of that. I wonder if that possibly contributed to it.
Yeah, that's a good point.
And I think we also need to acknowledge the speed at which information can be disseminated now. When we think about, when you were saying like the EPAs were formed in the 1970s, we didn't have the internet. So you couldn't just put something up on TikTok or Instagram or whatever and get it spread to millions of views. We have the capacity now. We're at a time in society where we can disseminate information so quickly and get it to a larger audience, which is exciting, but also scary. Do we have any other questions from the audience that perhaps... Sorry, I can see you pointing. Here, the lady in orange.
My question was for Brad. Have you published your PFAS and drinking water work, or can you provide any preliminary insights from that?
We're just about to publish one study. We looked at Gippsland. So there's a big PFAS contamination area around Sale. So we wanted to do a little test site. Actually the community contacted me. I gave a guest lecture and they asked us if we can measure the water down there. The really great news story for that study was actually the levels of PFAS in Gippsland were super low. And so, I gave a public lecture there, and it was about 150 or 200 concerned citizens there, and they didn't trust the local water authority. But then when I gave the data, then they trusted it. So far it looks like for that area, it was not contaminated at all. Look, there is PFAS everywhere, by the way. It's in the rain now, so we just have to accept that there's low levels until, I don't know, maybe we'll figure out how to get it out. But at the moment, we don't have the capacity to remove it at the levels that it's cycling through the environment. So that study hopefully will get published in the next 6 months in terms of the national levels of PFAS in drinking water.
Thanks, it's very exciting. Melbourne Uni's producing lots of information. I should just point out that as this is being live streamed, we are accepting questions from the online audience too. And you can do that by scanning the QR code and we will be able to answer or address questions that you have. You can also use that QR code to sort of vote against questions so we can see which ones the majority of people are finding that it is something of interest to many people. Sorry, did you have an online question, Beck, that you would like to ask us?
Yes, there's lots of people with questions online. We've got more than 110 people listening and tuned in. So, and they're voting for questions. And one of the top ones is, should we be filtering tap water? Is it actually necessary in Australia?
I'm going to hand over to the experts.
Look, it's a great question. In most instances, well, in Melbourne, I don't think we certainly don't. As far as I've seen in the water that we get out of our tap, we often use it just as blanks, so a blank method. So I haven't seen evidence of that in Victoria, but there are other locations where there is evidence that there is contamination. Typically, if your drinking water comes from a river, it means that and there's a town upstream, it probably means that the wastewater from the previous town has been discharged into the river, which will affect your drinking water supply. So in that instance, I would probably consider putting in a fridge filter. I feel like I've got a really long answer.
It's okay, we've got time.
I did this study in America. What we wanted to test was filters, right? And the grad student was running this project, and we poured water through filters for 4 days for 12 hours a day, and then we collected our samples. And then he went and ran the samples and hadn't validated his method and stuffed it all up, and then we had to do the whole thing again. So we had to do another 4 days of 12 hours of pouring water through filters, 1 litre at a time. Anyway, the point of that story is fridge filters work very, very well at removing pollutants. So, and the ones that I'd specifically recommend are granular activated carbon, GAC, and with ion exchange resin, and they will remove most contaminants from your water as a final polish. The Brita filters from your fridge don't really work very well. Please don't sue me. And the reason is, or based upon this study, is because they form these microchannels through the carbon, and therefore the chemicals don't get in contact with the carbon for removal. So you need to have a pressurised system if you think that you would like to remove the chemicals from your water.
Thank you. That's actually pretty interesting, because I think a lot of people would just think that it doesn't matter what kind of filter you use as long as you use a filter, but there's actually variations. Do you think... Do you agree? Or I shouldn't ask? You got nothing, you shouldn't ask.
I'd just maybe add that we're really lucky in Melbourne. I am so thankful to the people who set up our water system and made sure that it was in these dams that were surrounded by forests. And so we have all this is, we talk about ecosystem services, like nature doing the job for us. And that's what happens in Melbourne's water supply. And, this is one of the things for like how to keep us safe. We need to fight to make sure those forests and all of that buffer around all of our water systems stays in place, so our water stays as clean as it is.
Thank you. Now back into the audience that is here. I see there's a hand being raised right up the back. Did you want to ask a question?
Yes, please.
Just hold on for the mic so we can hear you.
Beautiful. I'm wondering what chemical or pollutant you wish the public to interrogate as closely as microplastics next, and then on the flip side of that, what chemical or pollutant issue do you wish the public to just shut up about, because it doesn't really matter?
Which is the easier of those two questions for you to answer?
That's a hard question.
See, I got this chemical group I'm super worried about, but no one knows anything about it. So they're called polychlorinated alkanes. They're typically found in massively high concentrations. They bioaccumulate, and they're really hard to do analytically. But there's no way I can get funding to actually do research on them. So maybe in 20 or 30 years, when we've shown all this harm, people might do some work. But anyway, that's the chemical group that I'm concerned about. The one that I get concerned about taking up a lot of oxygen is BPA. Now, the reason is BPA is an endocrine disrupting chemical that mimics estrogen in the body. It's a very, very well studied chemical, and we know a lot about it. It's rapidly metabolized and excreted from the body. We also know that, but the problem is the substitution that's occurring is with all of these chemicals we know nothing about. And so that's really where we need to think about how we manage this properly. So on the one hand, we know BPA is bad, and actually last year Melbourne Uni researchers found this association with BPA exposure for pregnant women and their male offspring having autism. So we need to be also very mindful of when people, at the times of their life when they're exposed as well. So BPA is one where I think potentially we're maybe creating a worse problem than originally existed.
Suzie, do you have a pollutant that you think, or a chemical that you think we should shelve, not worry about?
Stumped me. I'm going to keep thinking.
Victor?
It is an amazingly good question. So, and we're all automatically conflicted the moment we have to answer it. So, one group I really wish there was more. Oh.
You can't limit it to just one.
You're gonna hate it. You're gonna hate it because it's pollution, but it's not chemical pollution. It's noise pollution. That's the one that I'm most interested in, and that's the one that, look, there is there is demonstrable health effects from noise pollution with the learning effects or learning reduction effects and increased blood pressure and increased heart attack rate and all this kind of stuff. But it is really hard to get momentum on it because, except for one person, thank you very much, most people go noise pollution, right? So that's me, and I know it's a little bit off track, but in terms of, oh God, I'm so conflicted on the one that maybe we should talk about less. Okay. And I was so close to saying PFAS, but I'm not going to. Don't worry, I'm joking. Look, it is a very serious pollutant, okay? So let me be very clear, and everyone in this room will know someone who was affected by it, right? So it is a serious issue. But what has happened, I will tell you what it is in a minute, is that it has captured the imagination so much that it is causing worry when it is not an issue, and it's asbestos. That is the one, okay? Because you've each inhaled about 5,000 asbestos fibres today, right? And so, but as I said, when it's at high doses, when someone's exposed to a lot, and we know the horrible effects of it. So I do not for a second want to diminish that, right? That's not what I'm talking about. I'm talking about the concern around asbestos when it is not an issue, when it is completely bonded, when it is not being disturbed, when it is just ambient. That one, I remember back when I was at the EPA speaking to a lot of people who were losing sleep over it, and it was not an issue in those situations. So please understand, okay? No disrespect to the actual pollutant because it is a horrible pollutant.
I think that everybody understands, and you're being reasonable in the way that you've mentioned this. So I don't think anybody would take that personal offence to that. And it was a very astute question, and you definitely stumped everyone. So thank you for getting us all thinking. Do we have another online with the 120 people that are watching us, perhaps?
We have a queue of questions online, lots of questions. The one that's been voted to the top of the list comes from Sonia, and it says, what can we do as individuals to pressure government and industries to be more transparent about the chemicals in use?
I think you guys all vote, and I think it's really important. We don't necessarily always have a choice of how we vote. Pollution's not necessarily always at the forefront, but that is one of the big ways that we can pressure.
I think the way we're managing chemicals at the moment is incorrect, and we need to have a radical change in the way that we regulate them at the federal level. Now, Suzie outlined the approach that we currently use, it's called a risk assessment, where we do it by chemical basis. And typically, the evidence that that underpins those risk assessments is generated by research scientists, possibly at the university. And it takes decades to generate data even for a single chemical. So when we talk about this chemical universe, so I just talked about within PFAS, where there's 9,000 different ones. It would take thousands of people, hundreds of years to actually generate all of the information to make an assessment on the safety of those chemicals. So it's not possible for us to do it using the current paradigm. So there's another approach called the precautionary principle. Now, the precautionary principle says the lack of evidence shouldn't be used as a reason not to make a decision. And so if we could reasonably predict that a substitution chemical would have the same effect on the environment in terms of persistence and potentially toxicity, then we should make action there as well, rather than waiting. So at the moment what we have to do is we have to wait for the chemical to be released into the environment. Enterprising scientists have to then discover it in the environment, they have to run toxicity tests on it, and then eventually it will get phased out and potentially remediated. This is not a sustainable way for us to manage chemicals, and it does need to be managed at the federal level. And then we also need to think about not just importing chemicals, but chemicals that are in products. So basically building materials are essentially unregulated. So chemicals in materials can just get into the country. So we need to also be thinking about chemicals in our clothing, our electronics, and our building materials.
I think To answer your question, I think microplastics teach us a lot about how a chemical can make it to the front of mind due to people power. Suzie was saying it before. So when something really captures the imagination of the masses, first of all, yes, voting, no question, absolutely, that is so important. But also the choices we make with the products that we buy, the choices we make every single day, the conversations we have. Social media is very powerful and regulators watch it, right? So there are many, many ways of I don't know that pressuring government was that's perhaps not the wording I might have picked for it, but raising it as a concern with the government, absolutely. And also, if there was an actual concern that you had for an exposure that you were having, right, and I mean, so not just in general about a pollutant, then I absolutely would raise it with council or with the government or that kind of stuff, and they absolutely do address those questions. I remember I used to make the phone calls, so I know for sure that they do respond to them.
Thank you. So there's lots of different methods there, I think, that we've mentioned, and I think a lot of us can have access to be pushing that agenda. I've just been told that over that way is a bright light, which is why I've kind of been avoiding looking at you in that side of the room. I'm sorry, but I think that there's a hand up somewhere over on that side. Maybe down here at the yellow.
Just building on that other statement, can I ask who you vote for?
I think I'm going to say that's private.
It's up to you. Also, I think, am I correct in saying that our global sperm count is dropping by 1% per year? And did someone say we're down to 50% globally? Yeah, I said something like that. So is it linked to microplastics, or what do you think have you got any idea what it's linked to yet?
Should we pass? We have someone who does research on this in the room, our Dean.
It's a really good question, and I've got to say, as a field, it's something that we agonise over. So it's going to be a mix of things. So environmental pollutants are certainly part of it. Microplastics, the research hasn't been done, but it's also a mix of how healthy are we as individuals. So we know that adiposity, so people overweight, for example, sedentary lifestyles are associated with decreased sperm count as well. We also know that people who have low sperm counts, if they lift up their health, so that might be through doing, moderate exercise, drinking less, smoking less, eating healthier foods, their sperm count increases. So sperm count is a biomarker of overall health. Now, the scary part about it is, so that's good because we know how to do something about that. The scary part about it is, and Brad touched on this earlier, is depending on when the chemicals or the poor food or the whatever hit, it can actually reprogram fertility in males, which is what I work on, but also in females, and that effect might go over multiple generations. So you would have seen in newspapers that, what your grandfather ate affects, the health of the grandchild. So there is some truth in that, but on the good side, we know that all those things that, your parents and your grandparents said of eat well, exercise, helps to reprogram that. So we're not completely helpless.
Thank you. Another great question, but it also shows the diversity of the impact of these pollutants, and that we know that we've got experts on this panel that are looking at it from the chemical perspective, but also at this university we have experts looking at it from the perspective of how these things, or could these things, impact health, and working together and collaboratively is how we're going to be able to address some of those issues moving forward. I know both Suzie and Brad are working with teams from across schools, and Brad was saying he was doing some work with MDHS, so that's our medical medicine, dentistry and health science school, and that's really one of the benefits of working in a university like this, is that it's so big and there's so many experts. You can do collaborative work and come up with answers that you wouldn't be able to on a team on your own. Do we have another online question, perhaps?
Yes, we do. So top of the list at the moment is, how do newer pollutants like PFAS or microplastics challenge traditional environmental monitoring and regulation?
Microplastics are really odd in a way. They challenge every part of the current paradigm for environmental assessment. And the first one is we actually can't measure them very well. That sounds really simple. You say, oh, there's a bit of plastic. But actually, as you get really... So there's a couple of terms we use in analytical chemistry, and sorry, I'm going to geek out with you on this for a little bit. It's called accuracy and precision. So accuracy is how close the measured value is to the true value. Now, the true value is something we can never know, but that's what we try to do with our measurement. Now, when we do measurements for microplastics, accuracy is super low. What that means is the data reported in the scientific literature is not very accurate. And so this creates all sorts of problems, because how do you make decisions when the foundation of your measurements aren't very good? And there's a whole bunch of reasons I can talk to you about why the measurements aren't very good. The second problem is plastics really aren't just a single chemical. They're a complex mixture. And they can have chemicals added to them deliberately for all sorts of reasons. And BPA, which I've been talking about, is an example of that. The colours that we add into them as well are another example. So there's thousands of different chemicals that we deliberately add to polymers to give them specific properties for the application. So when we go to that risk assessment that we're talking about on a chemical by chemical basis, plastics challenge and break the model. And so we need to have a new paradigm for how we assess microplastics when we compare to a single chemical by chemical risk assessment approach.
Victor, did you want to add?
I agree completely with what Brad is saying. And I suppose when Brad says paradigm, that's very similar to when I say the machine. In a way, it's the same thing. And the machine is absolutely not equipped to deal with microplastics at all. And I would say microplastics are not the only one. So I'll might give you one or two examples of things I can think of that we're not equipped to deal with in our current framework. And by the way, it's also what I think universities can really help with, because that's where the creativity lies, right? And I'm a practitioner, I'm bound to the paradigm that exists. I can't operate outside of it. But researchers actually can be innovative and create new paradigms. That is the incredible power that research has, that I literally would be acting illegally if I did it, right? So one of the examples is, and Brad sort of stole it from me, was the mixed chemical mixtures. Yeah. Chemical mixtures are absolutely so. And did you notice, like, everyone in this room is thinking of pollution as one chemical at a time? And what you're doing is you're going on exactly the same journey that the entire industry went through since the 70s. And it always was one pollutant at a time, because that's what we liked to do, because it was nice to have a little book of a different color on each chemical. And now chemical mixtures are really starting to come up in risk assessment, and we do not have any half-decent method to really look at them. So that's absolutely one thing. Another one, if I might just throw it in there, is, the toxicology methods that we look at when we're looking at chemical substances, right? When we're deciding how much can be in drinking water and food and everything, they focus very heavily on the serious health effects, right? And I'm talking about mortality, cancer. Those are the health effects. Something that makes you perhaps a little bit drowsy, that I don't know how many mice you'd have to dose with it to be able to spot that effect and then say that substance in drinking water might do that. So they're called sublethal effects, but also the very mild effects. Those ones, this is my opinion, maybe I'm not exactly right, so please correct me if I'm wrong, but I think that they are flying under the radar a little bit.
Oh, absolutely, and I think lead provides a good example of that too. So lead is associated with violence, and that's not an endpoint we use in risk assessment. And so that's also how it managed to, fly under the radar for a while.
Suzie, did you have anything to add? No, that's okay.
I can, but I was thinking it'd be good to just go on to another question.
Yeah, no, sure. Do we have another online question, and then we'll come back to the audience?
Yep, they're still pouring in. So the top one at the moment is, how do researchers prioritise which pollutants to study when there are so many?
Have a go at doing that. So there's a number of different ways we do it. Sometimes it's what we can get funding in. So there's that sort of political, not as in like political parties, but just as in what's the sort of sexy chemical. Sometimes if we're doing collaboration with industry or government, it's the ones that they come and tell us that they're interested in. Sometimes it's because there's been there's some, report or something that something's a problem. And sometimes it's just because there's these sort of chemicals we've been hearing about and we're like, this needs to be tested. We need to work out, is it out there in the environment? Is it having an impact on organisms or humans? So there's a whole sort of variety of different ways that we can decide what to do research on.
Yeah, I think we just sort of trust our guts a bit, So, for example, I'm really interested in PFAS and I've been working on that for almost a decade now. And typically, firstly, it's super expensive area to do research in. The standards cost a lot of money and the instrumentation to actually do the measurement actually costs lots of money. So the equipment in my lab is millions of dollars worth. So that's also a roadblock for researchers to be able to enter the space to do pollution research. And in my group, typically what happens is the students say, oh, we found a new standard, can I buy it? And I'll say yes, typically. And then they'll put it into the method. And then that's how we found that novel PFAS in my blood, because the students had put it into the method. And another example of where we found novel chemicals in the environment was we were looking at Albert Park Lake. And we found for the first time this novel PFAS in Albert Park and the swans in Albert Park, which we believe could be, it's possible that this is from the Grand Prix. And I think the other area that Suzie and I are actually about to embark on a collaboration on is where we have, often there's well-intentioned things behind some of our practices. And lithium-ion batteries is a really good example of this, and the recycling of lithium-ion batteries. So they're full of like novel PFAS and chemicals that we have no idea of in terms of what they'll do to the environment. And so we're going to try to figure out, actually run some preliminary ecotox experiments to figure out what actually happens to them in the environment, because international studies are finding them in drinking water at very elevated levels.
And actually, I might just add a bit more on what you said. So there's a little bit of an order for how things happen. So firstly, someone like Brad will go out into the environment and go, hey, there's this new chemical that you might not have thought about before. And then someone like me comes along and says, right, let's do some toxicity testing. And so we're starting to connect that exposure, it's out there in the environment, to the toxicity to then be able to do the sort of risk assessments on it. So that is often a pathway that happens, yeah, which is why we collaborate.
Even though I'm not a researcher, I actually just published a paper in December with Pure Earth that was exactly on how you should rank chemicals. Actually, it was a recommendation of how the United Nations should rank chemicals for the purposes of then trying to get researchers to work on them. And I mean, there's a million ways. So, there was a lot of work that went into it in other ways. And by the way, the United States EPA and all sorts of regulators all over the world you can find a million lists on which pollutants should be researched, right? And without fail, they always look at the same thing, which is how much of the pollutant is in the environment, how toxic do we think the pollutant might be, and does it bioaccumulate? Those are the three things. And is it persistent and bioaccumulative? Sorry, it is both persistent as well. And those are the things, without fail, those are always the factors that get considered, which of course adds a bias in itself, because that is, of course, the way it works with these things. Can I add one thing? It's the only thing I'm going to say as a person who works in waste management, because Brad mentioned it before. One thing you should all do, do not throw your batteries in the garbage. They start fires, and fires have to be put out with water, and water can go into the environment. Right.
So there's another practical thing that we can do.
Sorry, you reminded me.
We should have spoken about earlier. And one of the things that both Suzie and Brad said initially is funding. And funding is a very important thing for us in universities. If there's anyone in the audience that wants to make a donation to the Faculty of Science, I'm sure we'll have it. But back to the online questions. Did you have another one for us, Beck?
Yes, we do. So a popular one, the most popular one is, are there some simple educational tools available to tell consumers what to avoid, similar to Victor's comments about avoiding EDTA, for example?
Because I raised it, I think I should talk to it. And it's going to be a disappointing answer, I'm sorry. the problem is there are too many sources of information, and some of them are genuinely incorrect. I'm sorry, but that is unfortunately true. Look, if you want the true, it doesn't actually tell you what to buy, but if there is a substance and you are interested in knowing how hazardous it is, the place I always go to is ATSDR, the Agency for Toxic Substances and Disease Registry.
No, don't make people read these documents.
There is a public.
They're 300 pages
thing.
long.
No. There's the public one at the front, which is only like half a page. It tells you how toxic it is. But I found so many pages that just lie about what you should buy and what you shouldn't. And I'm sorry. I wish there was better information, but I don't have anything on that.
Got a way that you can get information on what's in the soil in your garden. So we have a bit of an issue in many cities around the world with sort of legacy pollution from before we were regulating, from when we used to have lead in our petrol and in our paint. Lead's a big one, but there's also other chemicals. And our Victorian EPA has a program at the moment. It's called Garden Safe, and you can take some samples of your soil and you can send it in, and they of course will utilise the data. That's why they're doing it, but it also means you get data on your soil and you can use that to help you make some decisions about things like if you want to have a veggie garden, to make sure that it's safe the way you're veggie gardening.
So I think we are sort of, it's so great that everybody's been asking questions and questions online and questions in the audience. So before we go anywhere else, is there another question in the audience? I see that sorry, I'm being really rude to people on that side of the room.
Yes, I'm
it's
right
really
in the corner of your eye, I can see. Just a quick segue to something that Brad was talking about probably a quarter of an hour ago now, about filtering water. Brad, is there any evidence that the material used for filtering the water contains contaminants that are put in to replace the ones that are removed?
It sounds like you're talking about something specific. Is there...
Look, a lot of people, not me, but use water filters on our tap water. Is there any evidence that the water filter itself contributes to the pollution, the water that goes through that you drink?
I'm not aware of that there is.
That's fine.
Yeah, so... Yeah, you can. So typically it's activated carbon and there's an ion exchange resin too. So I haven't seen evidence that this is occurring.
So I do research with people in our engineering faculty, and at the moment we're collaborating on a project in India where they have a really big problem with arsenic and fluoride in groundwater. It's natural, but it doesn't really matter whether it's natural or not if you bring that groundwater up and drink it or use it to irrigate your crops or whatever. And they've done a lot of work in India. They've put in all these systems there to, deal with this problem and filter it out. And it's, that all sounds good. But so we have these students who've been going to India and testing whether they work. And I hope it's okay that I say this. We're in the process of publishing. But some of the things they've found is that these systems, they're not always, like the filters aren't replaced often enough. And so what can happen then is the filters can get full of the things they've filtered out, and eventually in some circumstances it appears as though they're releasing some of those chemicals back into the water, and so you end up then with more than you would have had originally in those situations. So I think it's not so much that there's stuff like coming out of the filters. They're made under pretty stringent conditions, is my understanding. It's more that if you don't change your filters within what the industry says you need to change those filters, then you could be just releasing it back into the water you're drinking.
I've learnt so much tonight about things I didn't think I was going to learn about, including filters. And I know that there's still more questions online, and I'm sure that there are still more questions in the audience. But unfortunately, we are almost at time. So before we finish up and before we let these lovely people go, hopefully you had an entertaining evening and that you were like me and learnt some new and interesting things. We started off in a little bit of a doomsday with Brad's sort of sombre interpretation of what's happening, but hopefully you did gain some insight into ways that we can, through making small steps and small changes and becoming more aware of the situation, actually make improvements. And the positive side of what Victor and Suzie and Brad have said, in that we are doing much better now than we were previously. It doesn't mean we stop, but it means that we can keep going in that direction. And by having functions like this, where you come along and you get to engage and ask questions, it's a really good way of creating that environment where questions can be addressed, can be asked, community can be involved, and hopefully we will be working together to push the problem forward. And it can't just rely on researchers, it can't just rely on industry, as we've said, it relies also on public pushing policies, pushing government, pushing decision making and becoming aware of the situation themselves. So thank you very much for coming along and contributing and for listening to our speakers. I'd like to thank them all for coming along tonight. So can you give them a round of applause? I'd also like to thank all of the people that are online for listening in, and we will have this recording occurring, so there will be a recording that we uploaded so that you can come back and listen to it again if you missed something. I'd also like to thank our Dean for allowing us to have these lectures and for organising them and standing up in front of us. And for anybody that is here and wants to stay on for a little bit longer, we will have some social time out in the foyer where we do have some refreshments and the opportunity to talk to one another. I know that there are other scientists in the room because I can see them, other chemists as well. So you never know who you might meet out there, and you can ask questions of people within our faculty and get an idea of what happens here within this school. But thank you very much for coming and thank you very much for participating. Thanks online.
Visit American City, you will find it very pretty. Just two things of which you must beware: don't drink the water and don't breathe the air. Pollution, pollution, we got smog and sewage and mud. Turn on your tap and get hot and cold running crud. See the halibuts and the sturgeons being wiped out by detergents. Fish gotta swim and birds gotta fly, but they don't last long if they try. Pollution, pollution, you can use the latest toothpaste and then rinse your mouth with industrial waste. Just go out for a breath of air and you'll be ready for Medicare. The city streets are really quite a thrill. If the hoods don't get you, the monoxide will. Pollution, pollution, wear a gas mask and a veil. Then you can breathe long as you don't inhale. Lots of things there that you can drink, but stay away from the kitchen sink. Throw out your breakfast garbage, and I've got a hunch that the folks downstream will drink it for lunch. So go to the city, see the crazy people there, like lambs to the slaughter. They're drinking the water and breathing